Great German, thanks very much. I'd hire that guy, whoever the guy you're talking about there. That sounds like a great bio. I want to thank everybody in the room for your dedication to be here for the last speaker of the last session of the conference. So you guys are the real hardcore wave energy team in the room here. So well done to you all. So let's get started on this stuff. Perhaps taking a slightly different tack from the other speakers today. And what I want to say starting off is, look, if you're going to build a wave energy machine, what are the kind of things that it needs to have? So there's a set of features. It needs to have a structure, a power takeoff, or we say PTO, foundations, moorings perhaps. There's got to be a maintenance strategy for the machine. There's got to be an installation strategy and so on. So there's a whole host of things that have to come together in order to have a wave energy machine. And if we look at the impacts of these components, so for example, if I look at which of these features of a machine contribute the most amount to CapEx, and you can see here things like the structure, the installation, the foundations, these are all major impacts on the CapEx of the machine itself. If I was to look at the same set of features and say, well, in terms of the OpEx, what are the key kind of things that have big impacts there? And obviously, the maintenance and operations regime are kind of the two key areas that have impacts on the OpEx of the machine. And then I said, okay, well, in terms of availability, which is critical to this industry, and it's one of the biggest, most significant things that influences your current levelized cost of energy. So if you have crap availability, then your levelized cost of energy is huge, and that's not a good position to be in. So I didn't count availability in terms of the structure, because if the structure doesn't have an availability, then that means it's washed up on the beach. So yeah, what does that do for your levelized cost of energy? So the other things clearly is the PTO, the mooring system, maintenance, control, operations, and I called it ancillaries, so everything else basically. They're the kind of things which will have the biggest impact on your availability. I wanted to relate this to our oyster machine. So the two most important impacts on the availability of our machine to date have been the PTO itself, how we actually get the energy off the machine, and a set of the peripherals. They're the things which have caused us the most heartache. You could call them failures, or you could call them learning opportunities. I prefer to go with learning opportunities because A, it means that I can sleep at night, and B, I actually like to think that I'm giving my investors some value for the money in the context of learning. So, kind of interesting to just muse about these things, but that's not really the point. The point is, whatever machine you have in the context of a wave generation machine, it's got to demonstrate a certain set of attributes. So survivability is clearly one of the most important attributes. And this is not survivability in those kind of seas that suit us. This is survivability in all seas. And I know some developers have strategies where they say, oh, well, if we've got a storm, we'll sink the machine to the seabed, or if we've got a storm coming, we'll tow it in. And that's fine if you've one machine, and I've no disrespect here, but if you've got 100 machines, then a strategy where, oh, we're going to sink them all to the seabed, or we're going to tow them all into the harbor, just doesn't work. So you got to think about the attributes, which is survivability in all seas. And again, availability. It's got to be in all seas again. And EMEC is kind of an interesting place to watch what happens with various marine wave developers. So 70% of the energy that's at the EMEC site comes to us between October and April. 70% of the energy in that period. But most wave energy developers tie their machine up at the harbor between October and April. So let's be clear, guys, it's got to be availability in all seas. And that means you've got to be in the sea, not tied up at the harbor wall. The next characteristics is in terms of efficiency. And again, it's not about being the most efficient. It's about being optimized for the sea state that you're in. In low seas, we want to get the maximum energy out of the machine. In storm conditions, then I don't care that much. If I'm only taking 10% of the energy out of the waves in a storm condition, I'm happy because I want to survive that storm condition. So we've got to think about efficiency slightly differently. And the one thing that we have to remember is up at the EMEX site, you've got about 20 kilowatts per meter of wave crest in the context of energy. But in a storm condition, that goes up to about 4.5 megawatts per meter of energy in that storm condition. So let's not be worried about efficiency in the storm condition. Let's worry about survivability. The other two drivers then are clearly cost, and that's CapEx and OpEx. And several people have mentioned it being commercial. Well, we have a market today which has established some sort of arbitrary number, which is 305 pounds per megawatt hour. The fact is somebody could change that tomorrow, and being commercial might mean that that has to be 205 pounds per megawatt hour, or indeed change it the other way, make it 462.5 pounds per megawatt hour. It doesn't matter. That's some sort of arbitrary established external number today, which is 305 pounds per megawatt hour. The next slide, I called it the truth about the industry, because I want to, for people to be real about where this industry currently is. I think it has huge potential, as Janine talked about. I think that there's tremendous enthusiasm and support for the industry, and you get a feel for that from the talk that Tim and Jacob just gave. But the fact is, survivability, we're not all there. One thing about Aquamarine Power's machine is you stick it in, it's bolted to the seabed. We don't have a choice of taking it in and tying it up at the harbour wall. We've allowed that machine to operate in all wave conditions, including all the wave conditions that we've experienced at the EMEX site. It operated completely through this winter. So I would say we've achieved a high level of survivability, demonstrated a high level of survivability. Not everybody else has done that. In terms of structure availability, I would say, again, very high. PTO availability, this is where we're weak. We have not demonstrated that we've got a reliable power takeoff on the machine. Others may have demonstrated something better than that. Overall availability for us, I would say, is low. For others, probably low to medium. Efficiency, and this is the thing, I actually don't care. We have a very highly efficient machine, but unless I get that availability that I need, that's a bigger overriding factor. In terms of cost, yeah, we're high, and so is everybody else. You saw it from Jacob's presentation there as well. It's too high. Today, it's too high, but we're only building one machine today. We've got a way to go. In terms of being commercial, again, achieving this arbitrary number, I'm not sure how long it's going to take us, but we shouldn't be over-ambitious here. This industry has suffered from a hell of a lot of over-ambition and under-delivery. And it's taken us 7 years to get to this point. It's taken other people 3 years, perhaps. It's taken some people, and I think you saw that from Jacob, it's taken them 16 years to get to this point. No disrespect here either. I think what we're demonstrating is it takes a long time to conquer this. And we shouldn't be surprised, because if you look at every other single technology, people say, oh, well, it only took wave a couple of years. That's rubbish. Wave energy has been around for thousands of years. Let's be clear about that. And even if we go back to the 1970s, when we started installing small wind energy machines in significant numbers, the 70s, guys, that was 40 years ago. So let's not be surprised if it's taken 16 years or more to get to this point. So here's what people say we need to do. We have to have the right regulatory environment, HSE, design codes, verification, all this kind of stuff, construction methods, project cost estimation. We need to understand marine operations better, mooring systems, O&M, materials, hydraulic systems, pneumatic systems, subsea cables and connectors, blah, blah, blah. It's kind of like, there's a list of things that people said that we need to do. I actually, first of all, that was written in 1999, and I would say that some of it has already been done, but I actually disagree. Thanks for leaving, guys. Cheers. Really appreciate you having stayed this long. It's good. That's me teasing, though. I'm sorry. If anybody else needs to go, just go. But what I'd like to say is that some of this has already been done. I actually don't care about the regulatory environment anymore. We've proven we have a 40 megawatt site on the west coast of Scotland. Do I need to prove that we have the right regulatory framework anymore? If somebody comes and tells me that we need to find more and better ways to monitor seabirds or marine mammals, no, we've done loads, years of that. I'm sorry, guys, I've done enough of that. Please don't tell me I need to do any more of that stuff. Do I need to understand construction methods and project cost estimation? Probably better, absolutely. Do I need to understand marine operations anymore? No, I don't. Mooring systems, yes. All you have to do is look at the things that have washed up on the beach in Orkney, and you say, yeah, we haven't got the mooring thing right yet. We don't use mooring systems, by the way. We just put a big hole in the ground and glue it in. Operations and maintenance, yeah, we need to understand more in this area because we haven't actually operated sufficiently the machines. We haven't generated sufficient power. We haven't operated them in anger for long enough. This gentleman here mentioned about materials. Sure, we don't understand the materials in this environment fully. We think we do, but we haven't yet. Hydraulic systems, of course. Pneumatic systems, well, there aren't many wave energy companies using pneumatic systems anymore. Subsea cables and connectors, absolutely. I've spoken at this conference previously showing you we put 180 connectors for instrumentation on the machine. All 180 of them failed from a reputable supplier called McCartney's. Control systems, I don't care about those guys. We've done enough. Yes, we can do more, but they're not, these things which are in green here are not things which are stopping us from actually getting these machines operating. They may not operate at the best efficiency. They may not operate with the best availability, but the fact that we haven't done something better on the control system doesn't bother me today. And the last thing, power quality and grid connection. We've demonstrated we can connect to the grid. We've generated power. Palamas has generated power. Some of the other guys up there have generated power. So let's stop worrying about, oh, can wave energy be taken by the grid? Yes, it can, guys. Don't worry about it. So here's my industry overview. It says the wave energy is poorly coordinated at present. All teams are working independently, and commercial considerations force them to keep their ideas secret. Yeah. There remains a lack of investor confidence and hence industrial support for the industry. Teams tend to be relatively small, working out of universities, blah, blah, blah. No major technological barriers to be overcome. However, some technological gaps have been identified. Does that sound about right? I would say yes. The fact is that that was actually written in 2001. Again, the stuff in the green I completely agree with. Except for the green bit at the bottom, that was a mistake. I'll come back to that. It says no major technological barriers, and let's transfer technology from other industries. The fact is we have taken oil and gas technology, and it sucks. We've had hydraulic system failures that are used in the oil and gas industry. We've had accumulator failures. We've had all this sort of stuff, all the McCartney cabling and so-called wet-made connectors all failed. And they're used in the oil and gas industry. The second point there, it says, you know, there's lots of other things, some technology gaps have been identified. Grid connection and energy storage. Rubbish. I don't care about grid connections and energy storage. Energy storage is the problem we have to solve. It doesn't have to be solved by the wave industry. It has to be solved by other people. We have enough problems to solve. So the top two things in green, absolutely agree with. The red ones, we still have a way to go. The next one I think is the one that's most interesting. This again was saying that we will have full-scale offshore power stations in 2005. Well, it's 2014. We still don't have those things yet. So what this is basically saying to us, guys, you know, we've underestimated the challenge associated, and I think that's reflected in some of the topics that Jacob mentioned as well. We've underestimated the challenge of getting this industry up and going. What I'd like to say, and forgive me for all the technical purists in the audience or indeed on the panel, but every wave energy machine has only 4 parts. A thing that interacts with the waves, in our case it's a big flappy thing, in Palamas' case it's a bendy thing. Then it has 3 other parts, the thing that makes electricity, the thing that reacts the power out of the wave, and the thing that keeps it in place. If I look at the first bit, the thing that interacts with the waves, this is just from Google Images. There's just as many of these as there are people who went to the beach and said, I understand how to design a wave machine now that I've seen a wave. Thousands of them. The thing that makes electricity, everybody needs one. Every single person needs one. And each one of us, we're all solving the same problem over and over and over again. fact is, somebody said it's like you have a 1,000-mile journey to go and you give everybody £10 worth of petrol. Nobody will get there. If you took 10 quid's worth from petrol and put it all into solving the problem of how to go 1,000 miles, then you might get a distance with it. Does academic research help? And somebody mentioned this in the audience earlier to a previous speaker. I would say yes. We have excellent relationships in applied research with 3 universities, which are going extremely well. However, pure academic research has not contributed to this industry because the academics like to work, some academics, let's not say all, never say never or never say always when you're arguing with somebody, but too many idealized assumptions. So the fact is everybody likes, monochromatic waves. Why? Because they're easy to model. Let's model heaving buoys. Why? Because they're easy to model. And then it kind of stops at that. So we need real focus on some of the other things. We are at kind of a crossroads in the industry, and what I would say is we have to change the way that we've been doing things. And I quoted Einstein here saying, insanity, doing the same thing over and over again and expecting different results. Somebody told me it wasn't Einstein who said that, but whoever said it was a very wise person. We have to stop doing what we've done up to this point, assuming that we're going to solve all the problems in the way that we have been funding the industry and in the way that we've been actually approaching the problem. So, a new direction is required. And, am I saying anything brand new here? No. Coordination between government, various government and grant funding bodies, academia, and the industry. An integrated pan-European approach to solving the key technological issues. We've tried it the other way, separately, and we haven't gotten there in the time, and we spent a hell of a lot of time and money doing it. A roadmap, the usual stuff, minimal red tape, and at the end of it, a wave industry. Right, I've said enough. Questions, please.
Okay, we've got time for 1 or 2 quick questions from the audience. Who's going to be first? Yep, down at the front on my right.
Hi, Alexandra Price. 2 quick questions. First, it's just interesting to note that you have put control really low down on your list of priorities, whereas Palamas feel that it's probably one of the top priorities. Second one is, what does academia need to do to produce useful research?
Okay, let's take the control one first. The fact is, guys, we have a machine which is out there in all waves, all weathers. Do I care about the control system? If I can eke another 10, 20% out of the machine, yeah, but sure. But is that what's stopping the wave industry today? No, it's not. And in the same way, with the Palamas guys, I don't work for Palamas, thankfully, but they have their own challenges. And if they need a better control system to get another better performance out of the machine, yeah, well, that's great. But the fact is, Palamas have bigger problems than that to solve. And one of them is, they need to be out there throughout the whole winter generating power. And let's assume they were out there the whole winter generating power and they were only operating at 10% efficiency. That would be a fantastic result. Now, if the following winter they go out and they have a brand new control system and they operate at 90% efficiency, well, that would be great. But the first milestone is one that doesn't stop, which would actually be a massive result to be able to operate through the whole winter with very high availability, even with a less than efficient control system. What does academia need to do? I think we've had some success. We've been working with 3 programs, the IDE Core program, the MARI program, and the DuraComp programs. These are all applied research programs where we're actually saying these are real industry problems, guys, that you have to solve. So what I'm saying is, rather than academia running off and say, oh, let's model another heaving buoy device, let's model another monochromatic wave thing interaction. Stop doing that, because I don't care, and nobody else cares, because it doesn't help move the industry forward from where it is. Silence.
Time for 1 more quick question and quick answer.
Oh, go on, give me 2. Give me 2, Chairman. 2 questions.
2 questions then, provided you answer them quickly.
Yes, will do.
Right at the front.
I'm going to time myself.
Okay, thank you.
Hello, Martin. Here's the man in the yellow shirt. You've seen me before.
Yes.
And on many occasions I've enjoyed your whiskey. And we've also enjoyed your enthusiasm and straightforward telling us where it goes wrong. And I really congratulate you on sticking your neck out and telling us. It's a pity there's so few here at the last to hear this most important report.
Is there a question in there? Because
yes.
it's giving me hell.
Yes, I'd love to make you some concrete structure to support your machine. Unfortunately, your machine requires an awful lot of steel, but I'd like to know how you are anchoring it, because my idea was that you'd have a large pontoon that would just go out and sink down there.
Fine. I have no issue with materials, guys. The fact is, we build a machine out of steel today. Could I build it out of concrete in the future? I'd love to. We're looking at composites in the future because that might be something that's important. I actually don't care about the structure today. Steel is nice to work with at this point in the industry, because if you make a mistake, you grind it out and you weld in a new bit. Try doing that with concrete, it's a bit harder. Trying doing it with composites is a bit harder. So, it's interesting, yes, we look at materials, but it's not the thing I need to do today. Last question, guys, because then the chairman's going to throw me
Final
off.
question right at the very back.
Poor chap with the microphone, you must be very fit. Oh, by the way, when you're doing... Oh, sorry, go ahead.
Yeah, hi, Martin. It's Max here. Max Karkas from Kailulum. Just a question, really, on the point you put there on cooperation and a different approach. I was just wondering what your thoughts were on that. Sometimes when that approach has been to try and force people together, it hasn't worked that well. But on the other hand, if you put the right kind of mechanisms in place, it can be incredibly successful. I think the wind industry and RISO is maybe a good example of that. So just interested in your thoughts on that.
Yeah, the fact is, where we're at today, Max, hasn't delivered the result that we needed. Now, I'm not just change for change's sake, but we absolutely have to try doing something differently. And the fact is, if we all tackle the kind of key industry-enabling technologies on our own, then we're all going to need to spend exactly the same amount of money over and over again. Whereas if we stop the bullshit about, intellectual property and all of that stuff and said, right, I actually don't care about any of the intellectual property other than the intellectual property in the thing that does this. Any other intellectual property I have about control systems and power offtake systems and all of that, it's not actually that important to me. This is what my unique advantage is, this piece of the technology. And I think a lot of people are, as it said in that kind of summary back from 2001, they're worried about their intellectual property and intellectual property leakage, and that's reasons that we can't cooperate. But guys, we've been at this a hell of a long time and we haven't gotten there. So we have to stop this idea of overprotecting our IP and get on with actually delivering these enabling technologies. How you do it, I'm not saying that there aren't challenges in that, but we have to be realistic. We're not going to get there. Now, we have an industry program ongoing at the moment. I'm actually not allowed to say who it's with, but I hope to be able to say that very soon publicly. And it's tackling one of these key industry enablers. And we're looking at bringing Carnegie in as a potential partner and also a couple of other wave people as well. So we want to solve this problem once with several wave companies, all of them having access to that. Thanks very much. And thanks, Chairman, for giving me the extra question. Appreciate it.
My pleasure. Okay, well, thank you, everybody.